Okay, Rockstars, now we move on to the final review video of the day, and that includes mixtures and solutions. Okay, and this was a day that we ate a little bit. You probably remember this way back from 3rd grade, okay, especially those of you who had me, when we took Kool-Aid, put it into water, okay, we talked about why that's a solution. We made mixtures, with trail mix, different things like that, but now I want to dive a little deeper and look at some things that, might not be as clear as those two things. So put this somewhere on your poster, mixtures and solutions, and I want to get down to the definition of each. What does it really mean? Because we talked about, since we learned about the properties of matter, okay, the observable and the measurable properties, how does that relate to a mixture? Okay, so you can look on page 614, 615 in your textbook. We looked at that in class. These are some pretty common mixtures. They had fruit salad there. They also had a pile of laundry. Okay, some other mixtures that we made. Remember that mixture we made right before we went to lunch? I think we took water and we put flour into it, mixed it around. We're all like, oh yeah, that's a solution because the flour has dissolved. Okay, but then when we came back from lunch, we realized that the water had separated from the flour, so it was actually a mixture and it wasn't a solution. Because the properties did not change. Okay, when properties do not change, if I take my phone and if I take this book, and if I take this marker and I put them together, the properties remain the same. Okay, it still looks the same, it still smells the same, it still touches, it still feels the same, not touches the same. Okay, and it probably still has the same mass, density, and volume. Okay, if I took this marker before I put it into my mixture of 3 things, measured the volume of it, I'm sure it's the same as when I added it. It still has the same volume. So a mixture is when I combine different substances together and they retain their properties. And it can be easily separated, okay? But we did talk about some processes that you might have to separate. If we take sand and water and we put those together, yes, that's a mixture. We could separate that by using a filter, okay, or kind of a net. And we could, pour the water out of the sand and the water would separate and the sand would be there. And so water and sand mixed together would be a mixture. Okay. Now the solution was a little more confusing because anytime you combine 2 substances and you put them together, you have yourself a mixture. So we talked about how every single solution is a mixture. Okay. Every single solution known to man is a mixture. Not every mixture is a solution. Why? Okay. So if I took this water in this cup that I had earlier, okay, and I put Kool-Aid mix into it, imagine that I have imaginary Kool-Aid mix, guys, because I don't have any Kool-Aid mix at home. Okay, so I mix it in, stir it around, and remember when I had you guys put that into your water bottle, and then I said, okay, I just forgot. I didn't want you to mix that in. And everybody was like, I can't take that out. Okay, you weren't able to take your Kool-Aid mix out directly. So a solution can be separated, but it has to be separated through what? What do you think? Through evaporation, yeah. So anytime that something dissolves inside of another substance, you have a solution on your hands, but it can be separated in the end through evaporation because we talked about the fact that matter can neither be created nor destroyed. Now, I have a page in your book that I want you to look at really, really quickly that describes mixtures and solutions, or it gives you some scenarios. On page 622 in your textbook, go there really quickly. There are 4 examples. Okay, I'll read the first one so that we can get through that one. Then I want you to do the other 3 on your own. Number 1, when you combine ingredients to make a sandwich, each ingredient keeps its identity. You could easily separate them. Mixture or solution? Good, that's a mixture because all parts of the sandwich keep their identity. They have the same properties. So therefore, that would be considered a mixture. Okay, so make sure you have down mixtures and solutions. Big, big, big topic that we talked about, and I want you to tie in the idea of properties, okay, into these definitions and find some way to creatively put it on your poster.